Hi, welcome back to the breadboard. This is day 6 of our 7-day Texas Instruments Internet of Things project. And today we're going to add a nice smart device interface for our IoT node to react to. Yesterday we added Internet of Things capabilities to the node, and we went through how we can get the CC3200 to send data up to an MQTT server on the internet and also subscribe to data from it so that we can tweak the high and low set points. And we also adjusted the display a little bit to make it look a little nicer, as you can see here. And we add by adding the high and low threshold points so that you can see it by looking at it, and add a status of what the fan is currently doing. But this just worked in automatic mode as far as the local screen is concerned, and it's going to stay that way. And we just used the MQTT lens to adjust the high and low set points, and that's all we could do with it, was just adjust these set points, and everything else was just working automatically. What we're going to do today is we're going to update the display, and as you can see here, the only real difference you can see right now is the fact that there's this auto dash. The next thing is we've done a few modifications to the code. I've added more capability to the code. And what I've added is the ability to switch between auto and manual mode, and also in manual mode to be able to turn the fan on and off. We already had the ability to publish to the MQTT server the high and low threshold values, and now we can publish the desire to run in auto or manual, and if you're in manual, whether the fan is on or off. I'm going to then show you how we can create a very quick and functional smart interface so that you can use a smartphone or a PC or a laptop or a tablet, whatever you like, to get access to the smart device. And what we're going to end up with right here is my smartphone. Let me just bring up my browser. So this is the interface that we're going to build. This interface is talking to Node-RED. In fact, Node-RED is what is hosting this web page that's being shown. It's an HTML5, and you can see there's a few sections to it. The first one is we've got a trend display that's actually showing us the temperature of our sensor that's attached via the end of this cable here over the last 24 hours. We also have a little gauge here which shows us the current reading, and as you can see, this is live up here. You can see it ticking away. And if I put my finger on the temperature sensor and start cranking it up, as you can see here, it's rising here. So in a moment that should update. There we go. And it's just a little bit behind. It's just catching up. This is all disconnected and going through to the MQTT server and then back down to a Node-RED instance that's running on a Sitara Texas Instruments processor, which is actually running Linux in a virtual environment. I wanted to run it on a Beaglebone Black, but I don't have one right now, so I've just got the nearest thing, which is one of my industrial PCs that I had, or industrial microcontrollers, is running a Texas Instruments Sitara processor in its core. So it was running Linux Jessie, and I've added Node-RED to it, and I've created this interface so that we can have a smart device. And it's actually subscribing to the data that we're sending up into the cloud to the MQTT server. So here's the temperature. You see the graph is now updated with my little temperature increase that I just did with putting my finger on the sensor, and it's just starting to come down now. If I scroll down here, it's showing our current value and our temperature. These are also coming from the MQTT server via Node-RED. And what we also have here, in the session we did yesterday, I was actually using the publish capability of MQTT Lens to manually send some different values. What I now have is the ability to just tweak these sliders. So if you look at this, it says 28.51 right now, and that's reflected also here. If I just click on this and rise it up a little bit, it'll take a second to go through the motions because I'm remote taking over, and it's got to publish to the MQTT and then come back, etc., etc. The range of this is 0 to 50. You can see already that up here it has taken effect. It now says 37.94, and then that's been also published out to the MQTT server, and in a moment it's going to come back and be reflected on this one here. While we're waiting for that to catch up, the other thing that I've also added are a couple of control buttons that allow us, there, you just caught up there. We've also added a fan control that allows us to do auto, manual, and on-off control. So if we're in auto, which is where we're at now, this control will have no effect. In fact, if I just turn it on right now, it's not going to have any effect. So it's just come on. Obviously, the fan is already on at the moment. I take the temperature above the high threshold, and it come back down to 25, but I currently have the low threshold set to 21. So let me just let this come down a little bit again. And let's increase the low threshold, and you'll see, I'm just going to increase it a bit just to bring it more into the range of what it's sensing. We should see it actually turn the fan off. So I've set it to 26.4, so as soon as this goes below 26, it should turn off. And there, it's gone off. Okay, so that's good. And now we're in auto mode. So what I was going to show you was if I turn this on, it's going to have no effect right now. Right? It's had absolutely no effect. Turn it back off again. Now what I've also done, I don't have the fan connected here because I'm actually in my office with all of this hooked up, but just on the edge here you'll see that I've actually hooked in a white LED. So if right now I heat this sensor up again and take it back to the on, you should see this come on. It will go white. There, so it just came on. All right, that's just a standard white LED that I've connected to the data pin that we'll be using. And as you can see, if you can turn an LED on, then it can control a transistor to a relay and turn anything else on. I hope you'll believe me when I say that, and you'll be able to move forward. So what I'm just showing you here basically is that I can control the high and low set points. I can go between manual and auto. Actually, I haven't shown you that yet. So let me just go to manual. So right now the fan is on. If I turn this to manual, if it gets picked up before we go to the low value here, no, we didn't quite beat it. So it's manual and the fan is now off. If I come down to the interface and I actually click on, it'll take a moment. We'll see this right here come on, and there the light has come on, indicating that it's sent a signal out to the fan. So that would now have the fan turned on, and I can turn that off again. So you can see here that we now have full manual control if we want it. We can go back to automatic control. We can adjust our set points as much as we like between the range of these sliders. We are seeing on our phone the current value and the current temperature and the current temperature values and the elapsed time since this node was turned on. And we're seeing a graphical trend of the temperature, and here's where I was putting my finger on the probe. And we have a little gauge indicating the temperature. Now, what am I using for this? Well, we're going to go into that in just a moment. So before we go into the graphical design, let's go look at the Energia code that I've done to modify this. So here is my code, and the main thing I've done here, if we quickly scroll down, I'm only going to highlight where the differences are. So I've added a couple of some additional variables for the fan. I've added a fan state, an auto fan, which is just a boolean true or false, which says whether the fan is in automatic mode or manual mode. And I've added a fan man state, which means that if it is in manual mode, this is the state of the manual command that I'm setting. That way you can have a manual on-off and a separate automatic on-off. Scrolling down, the next thing we've added are a couple of additional subscriptions. Actually, yes, we've added the auto state and the manual. So we've got auto and manual subscription, and then we've got the publish topics, which is the temperature, the fan state, and the time. Coming down here in setup, there are no differences. In our main loop, there is no differences. Oh, there is one difference, sorry, that I added. The client.yield, which was in the MQTT update routine with a 500 millisecond delay in here, I've moved it into the main loop with a 50 millisecond delay. The reason I've done that is because it makes the node a little more responsive to any publications that are sent to it from the MQTT server. So now it's running through here it's going to go as fast as it can when there's nothing to do, and then it's going to have a 50 millisecond look at the received buffers, and if there's anything there, it will process them, and if there isn't, it's just going to come back and loop through again. This has a lot less impact than having a half-second yield in the MQTT publication update function. So scrolling down, I've added two more, which is message arrived auto, which is so if we send a topic for auto or manual, it's going to get processed by this. And we've also sent another one, which is message arrived manual fan, which means that if you're, and what that results in is you're able to set a Boolean to say, if I'm in manual, do I want the fan on or off? The other thing that I've added to these, yesterday I mentioned that there was a little bit of risk with the handling of the messages because there was no protection around them. And one of the other things that I found was in here with the message payload, there's a buffer that's set up for this. And when new messages come in, it actually doesn't clear out all of the payload. So if you had a string that said 55.44, and then later on another temperature setting came in that said just say 22 without any additional content, or a message came through that was just saying 1 for a different topic because it was going to be, say, turn the fan on or something. The remainder of the buffer that was from a previous message would not be cleared out, but there is a payload length indicator that also comes in with the message. So what I've done is I've set up a local character buffer where I create one just a little bit bigger than the payload to allow for the null termination at the end of it. I copy the message that came in, but only the number of characters that are part of the payload, and then I terminate it with a null, and before I do the conversion to integers and floats and various other things. So I've done that for all of these 4 routines, and that has completely cleaned up the ability or minimized the risk of corrupting the data and things. I'm not saying it's infallible, it's far from that, but at least it's made it a lot more efficient. The connect has also been modified slightly. Before we had only 2 subscriptions for the high and low values. I've added the 2 other subscriptions now for the auto manual and the manual fan control. And that is pretty much it. That's the only changes that I've actually made to the application, and I will be publishing these up onto the internet so that you can actually get all this code. So what is the next piece of what we're doing here? Well, we've got to look at Node-RED. If you haven't seen Node-RED before, I think you are missing a great opportunity with the Internet of Things. What it is an application that allows you to graphically design a process control. It's designed for laying out a flow, a little bit like a PLC control. So this is the instance of Node-RED that's running under Debian Jessie, and that is running on the Sitara processor on a Mica control unit that I have. When Node-RED comes up, you've got an administration screen here, which is where you can design your workflows. Now, I have a couple of other workflows already here for a different application that I'm playing with. The one we're interested in is this flow 1 that I've created that is actually generating this smartphone interface. But that exact same interface, you can see here the URL 192.168.1.204:1880. It is the exact same interface as I'm looking at here, but this is on a Chrome browser on my PC. And you can see it will adjust width-wise, and if I just shrink this down, it's going to automatically in a moment just resize itself, right? So it's gone more now like the smartphone is. But the nice thing here is that really, as long as you're supporting an HTML5 browser, you can bring up this interface and control your application. Now, Node-RED also lets you set authentication and things like that, so you can secure it if you want to. And this is just happily mirroring everything that's on here and everything that's on here. So these 2 displays are synced up. So if I actually change a value here, let's just say I take up the high set point, you'll see here it's going to reflect that any second automatically. So if I try and adjust some of these set points, like if I go down to the phone interface and adjust the phone down a little bit, you'll see that it's in a second it will come down. All right, so it's come down here, and it's automatically come down on the other display, and it's also come down on the CC3200, which means all of these things are staying in sync. Anyway, going back to what we need to do. So this is what Node-RED is producing for us. If we go over here and have a look at Node-RED interface, what you do is you have all these widgets, if you like, for want of a better word, on the left-hand side here, and you can just drag them on the screen. And what these ones are, these pinky purple ones, they are MQTT subscriptions. Here's some output MQTTs, and at the top here we have input ones. And what you do is you just drag it on the screen and just drop it. You go into it and you can tell it what your server is. So we've got a local one here, or we can go out to Eclipse. You tell it the topic you want, and then you just give it a name, which is just shown inside the boxes. So if I look at one of the ones I've already done here, let me just delete that one off the screen and go in here. You can see iot.eclipse.org, and this one is going to subscribe to temperature. When this gets deployed to the Node-RED server, it's going to automatically make its subscription out to the MQTT server. Whenever that server sends any data to this will pick up on it and actually send it through these virtual links to these different items that are on the screen. So this top one is going to come out to this function block where you can just put a bit of JavaScript in. And what this is doing is receiving the payload, converting it to a string, and then sending it forward. So the message.payload is just going to go to the next node. So it just takes the value, makes it into a string, and then we just put it onto this temperature display here. This is just a text box that will appear on the screen. I've told it to put it into a group called current value, and if you look over here, that's this one. And I've told it it's the message payload, which we just converted into a text string here, and after it it's going to say degrees C. And if you look here, that's this one here, and then there's the value that gets converted from message payload, and there's the text bit that says degrees C. And if we look at the other one for the elapsed time, you'll see a similar thing here where we convert the binary value that came into a string. And then we do the same thing where we take the value from the payload, and then we just add the word seconds after it, and that's this one here. And that's what both of these are doing. They're just converting it, and then these are HTTP outputs. Node-RED supports a user interface if you load in the UI add-on for Node-RED, and all of these blue boxes are actually user interface display icons. So they're going to come on the screen here. You've got gauges, text boxes, graphs. This temperature one is the one that's actually producing the graph here. All right, and it can automatically trend over different periods. So here's all the setup for it. I've told it that keep data for basically 1 day. I can change that to seconds, minutes, hours, days, weeks. For the fan control, I have an actual template here. Now, right now this is not working because I actually originally had it on a different server with an icon, and I haven't got the icon here. So right now this is not doing anything. But if I actually go in here and modify this, right now it's actually trying to put an image. So it's going to say status. And right now it's trying to put an image in there that actually doesn't exist. So what I'm going to do is I'm just going to quickly modify this. So instead of having this image, I'm just going to convert it so that it actually just puts some text there. So if I delete that from here, get rid of the ending of the image tag. Hopefully I'm going to get this right. I'm doing this live in front of you guys. And I'm going to, instead of this, I'm just going to say message.payload if it equals 49, which is 1. I'm just going to put the string running, and if it is a 0, I'm going to put the string stopped, and that's it. So I just say OK to this. I hit deploy, and let's see if this is going to be reflected. That one's done. So go back to TI week. So the fan is off. We're in auto mode at the moment. These won't always, I'm not actually sending the auto manual from the system right now. So if this is not reflecting it, then it's just a case of turning it off and back on. So now if I go off, it's going to send the manual subscription, which as you can see, that's changed immediately up here. Now if I turn this off and then back on just to actually send the on publication, that's turned it on, and this should now change to running in just a few seconds. There you go. So now it's reflecting the fact that the fan is running. So let's just test the automatic functionality of the on-off and make sure it reflects the running and not running over here. So right now it's showing stopped. We're in the mid temperature. Actually, we're a little bit below the low threshold. So we'll warm up, see if we get to 28. There it is, turned on. It's showing on here. The lights come on. We're showing running here. So now it's cooling down again. As soon as it gets below 26.4, it should turn off again. So that's any time now. That's gone off, and it showed stopped here. So now if we go to manual mode, this will change to manual, and nothing else is happening right now. If I turn this on here, it should come on here, and any minute it should reflect running down here, which it is. So there we have working status indications and everything else. We have the current values, which are being updated nicely. If I put my finger on here, see it's coming up, and we're going to see another little spike on here as it refreshes. There we go. Take my finger back off again. That's how easy you can actually create a smartphone interface. I have plenty of videos on my YouTube channel that shows how to install and use Node-RED, so I'm not going to repeat that exercise here, but by using Node-RED and simply dragging in a few controls onto a page, connecting them up and having a little bit of simple JavaScripting, you can create a pretty functional user interface that will give you nice information. And if you want to do your own UI, you can. I'm just using Node-RED for this. There are other applications that will give you a much nicer display, but you may have to spend a few dollars. One of them is a program called ImperiHome, which I use, that talks to one of my other Node-RED instances. In fact, I think I even have it on my phone right now. If I just bring this up and try and have a look. This is a smartphone application. This one is actually talking to a different Node-RED instance, and you can see here that it has a whole bunch of controls that are up and running. And I think if everything is working correctly, I should be able to go into, say, this temperature and see a graph of the last 2 weeks worth of data. Now, ImperiHome is an application that costs about $5 or something. It's very economical to buy. It's got a lot of functionality and is very well supported in the community. The ImperiHome application, you can connect it to Node-RED, you can connect it to a whole bunch of different technologies. Smart lighting, thermostats, all sorts of stuff. And if you look at the ImperiHome website, you'll see what it can connect up to and how easy it is to connect to Node-RED. Both Node-RED and MQTT are both fully supported and run by IBM and amongst a bunch of other collaborative vendors, but IBM is the prime for it, and so you've got a lot of support for these applications, and they're free. That's the one nice thing about it, is that they are completely free. So anyway, I think that about covers it. I know I haven't gone into a huge depth for Node-RED or for MQTT. Really, I just want to show you that you can make smart interfaces quite easily and get them up and running with very little effort. In this particular case, we are using a remote MQTT server, which obviously here is adding a little bit of latency, but nevertheless, it still worked. For this Day 6 of the Texas Instruments Internet of Things, I'm going to close this off. So tomorrow, on Saturday that is, we will have a look at adding battery power to this and potentially a solar charging capability as well. So I hope you enjoyed that, and now that we're at this point, we have a pretty good system up and running. We're fully internet enabled, we're participating with an IoT node, we have a smart interface that can also be accessed via a browser on any desktop, tablet, or even a smartphone. And it means because it's on a smartphone and because you're able to have this basically accessible through your home network, or you can use online services to be hosting Node-RED as well, then you can easily get this thing up and running pretty much from anywhere in the world. Now, the other thing, like within Perihome, there are other applications that you can get that will allow you to interact as well with a much nicer user interface. And you can also, even within Node-RED, I've just used the standard UI elements to create this one because I didn't want to make this any more complicated than necessary. But if you're savvy with HTML and JavaScript programming and everything else, there's nothing to stop you completely making your own HTML5 interface using custom graphics and better controls rather than using this one. With MQTT, you can actually have a browser directly talk to an MQTT server, so you wouldn't even necessarily need to go through Node-RED. So that's something I'm going to go into on another video in the near future. But for now, I'm just going to finish it here and say we've got a smart interface. It's functioning. It works better on other phones probably than mine currently right now. Definitely works on desktops, tablets, etc. And we're able to control our IoT node from afar. I hope you agree that just using the LED indicator instead of having the fan physically connected is still a true indication that we can control a device remotely, and we will have this thing up and solar powered and everything else on Saturday, so tomorrow, and that will complete the week.